All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for this factoring, we're going to factor it as x cubed, and then we're going to use positive 3 and negative 1. Now this x cubed plus 3 will not factor further. However, x cubed minus 1 will factor as a difference of cubes, so we'll have x minus 1, and then x squared plus x plus 1. And so this would be your answer for your factoring. For the math knowledge question, it asks about a complete factorization here. Well, all of these have a 2 in common, and they also have an x in common. And so if we pull out a 2x, we're left with 1 plus y plus 3xy. And so that is E. So that'd be your answer for your math knowledge question. So we are looking at lesson 112 today. We're looking at the binomial theorem. So hopefully you'll understand the binomial theorem after this lesson. It's related to Pascal's triangle, but instead of using Pascal's triangle, we're going to use this formula. If n is a positive integer, and so it's going to be your exponent on your f plus s to the n, and k is a positive integer that is less than or equal to k plus 1, then the k term of this is going to be given by this formula. Now, I know it may look a little strange, but this right here, n minus k plus 1, is the same exponent here, n minus k plus 1, and then we have a k minus 1, which is what is your exponent on your s. Now, n minus k plus 1 plus the k minus 1 actually just equals n, because your k's cancel and your 1's cancel. So these two numbers in your denominator are always going to add up to n, whatever your n is, whatever your exponent is. So that's your formula. You do need to memorize it. I'm going to show you how to do that, how to use it on the next page. So we want to find the 8th term of the expansion of f plus s to the 12th. So we're going to use our formula. Our n is 12. So we have 12 factorial. And then we have 12 minus k. Well, our k is 8 because we're looking for the 8th term. So we have n minus k plus 1 factorial. And then we have k minus 1. And then we have f to the 12 minus 8 plus 1, s to the 8 minus 1. And so now we simplify this. 12 factorial over 12 minus 8 plus 1 is 5. So we have 5 factorial, and then 8 minus 1 is 7 factorial, and 5 and 7 do add up to 12. And so we have f to the 5 and s to the 7. And so now all you need to do is plug in 12 factorial over 5 factorial, 7 factorial into your calculator. And so you get 792 f to the 5th, s to the 7th. And so that would be your answer. The reason this binomial theorem is good to learn, you don't want to have to write out Pascal's triangle to the 12th row. That's what you would have had to do if you did not know the formula that we just looked at. I personally don't want to have to write out that many rows of Pascal's triangle. If you just do not want to, you can. However, you're never going to finish your test because you're going to run out of time to do that. So I recommend learning the formula. It may take a few times before you learn it, but you do need to learn it, okay? So now let's look at another example. We want to find the 10th term of the expansion of f plus s to the 14th. So if you had written out Pascal's triangle for the last one, you'd have to add to it to get this one. It just doesn't make sense. You need to learn the formula, okay? So our n is 14, because that's our exponent right here. So we're going to have 14 factorial over 14 minus 10 plus 1, because our k is 10, because we're looking for the 10th term. Then we're going to have 10 minus 1 factorial. Then we're going to have f to the 14 minus 10 plus 1, and s to the 10 minus 1. So now we have 14 factorial over 14 minus 10 plus 1 is 5, and then 10 minus 1 is 9. And so then we have f to the 5 and s to the 9. So then you just simplify that with your calculator, and you get 2002 s to the 5 s to the 9. And so that would be your answer for this one. And so that would be the 10th term of this expansion. On these, when they have such large exponents, they're never going to have you write out all of the terms. They're only going to ask for one at a time. Okay? So let's look at another one. We want to find the 10th term of the expansion 2x cubed minus y. So we're going to use our formula where our n is 15 and our k is 10 because we're looking for the 10th term. So we have 15 minus 10 plus 1 factorial, and then 10 minus 1 factorial. Now our f is no longer just an f. It's actually 2x cubed. And it's raised to the 15 minus 10 plus 1. And then our s term, our second term, is raised to the 10 minus 1, and it's a negative y. Remember, you do need to take that negative with you. You got to take the negative sign. So we have 15 factorial over 6 factorial, 9 factorial, and then we have 2x cubed to the 6th and negative y to the 9th. So if you simplify those factorials, you should get 5,005. 2 to the 6th is 64, and then we would have x to the 18th. And then negative y to the 9th is going to be negative y to the 9th. And so now we need to multiply 5,005 times 64 times negative. And so we get negative 320,320. And then we have x to the 18th and y to the 9th. And so that would be your answer there. So again, you do need to memorize that formula. If you practice with it, it should get a little bit easier. But you do need to memorize it in order to do these quickly. Your homework, you do get to omit number 1. So make sure you do the rest of those tonight so that we can go over any questions you have tomorrow.